Question 7. A gas syringe that does not have any graduations is calibrated using no mass of propanol. Boiling point is 56.2 degrees Celsius. The sealed gas syringe contains this 0.146 grams of propanol, MR equals 58.0 at a temperature of 95 degrees Celsius and a pressure of 103 kilopascals. Calculate the volume in this. Now that's really key, in centimeters cubed, because if we use the correct units in obviously the ideal gas equation, PV equals on nRT, the volume we're going to get is in dm cubed, but we want it in centimeters cubed. So that's the key thing, and I feel like that's why it's worth 4 marks, because that final mark to trick students out. So we'll just rearrange it. We get V equals nRT over P. V is equal to number of moles, where number of moles is the mass of propanol divided by MR, 58, times by R, which is 8.31, times by temperature, which is 95 degrees Celsius, but obviously you want that in Kelvin, so 95 plus 273, so 95 plus 273, divided by pressure in pascals, that's in kilopascals, 103,000 pascals. So I get 0.146 divided by 58 times by 8.31 times by 95 plus 273 divided by 103,000. I get 7.47 times by 10 to the power minus 5. But like I said before, that's in dm cubed. We want our answer in centimeters cubed. So we're not going to divide by a million, we're actually going to times by a million. So we're going to times by 1 times by 10 to the power 6 and get 74.7 centimeters cubed. So we can leave as that, 74.7 centimeters cubed. 7.2. The gas syringe is then cooled to 75 degrees Celsius without changing pressure. Calculate the decrease in volume. Now what we can do here is, we know that the volume is 74.7, so to find the decrease in volume, that's 75 degrees Celsius. 75 plus 273 divided by our original temperature in Kelvin, 95 plus 273, 368. And you get a decrease as 4 centimeters cubed. Or you can do PV equals nRT, find out the volume using that way, and then do this volume minus this volume, and then you'll get an answer of 4. At some point 3, total uncertainty in using the balance to measure mass of propanol is that. Calculate uncertainty that this causes in the volume of propanol. Calculating question 7.1. Well, we know the percentage uncertainty is going to be therefore the total uncertainty 0.001 over the mass, which is 0.146, times by 100, which will give me 0.685%, and therefore to find the uncertainty that causing the volume in centimeters cubed of propanol, all we do 0.685 divided by 100 times by 75, and you should get 0.5 centimeters cubed. So we're just going to times this divided by 100 times by the volume, which is 75 or 74.7. And then 7.4, a 600 centimeters cubed sample of propanone is mixed with 2800 centimeters cubed of oxygen in a container of this and this. Now we're not going to need that for this question, it's only 2 marks, right? I doubt they're going to expect us to use PV or color NRT. We could use it, but this is a simpler way and a more logical approach that they want to really test. They want to test in this question. When the mixture is ignited, when the reaction is complete, the remaining mixture of gas is equal to 60 degrees Celsius at 100 kilopascals. So same as before. Calculate the total volume of remaining gas mixture. So we know 600 centimeters cubed sample mixed with 2800 centimeters cubed of oxygen. Let's look at the moles. That's a 1 to 4 molar ratio. So if we start with this sample of propanone, therefore that tells me 2400. So that tells me that actually only 2400 centimeters cubed reactive oxygen. So therefore, if this is how much we have of oxygen, and 600 is the moles of propanone, is 1 to 4 ratio, 600 times 4 is 2400. Therefore, to find the remaining oxygen in the mixture is 2800 minus 2400, 400 centimeters cubed. Okay, now that's not it. That'll probably give us 1 mark. Second mark is while identifying this and this is a 1 to 3 molar ratio. You have to find out this. We're just going to do 600 times by 3 to give me 1800 centimeters cubed of CO2. Now that I've done that, I can just do 1800 plus 400, which will give me 2200, and therefore 2200 centimeters cubed is the total volume of the remaining gas mixture. Now H2O, the value of H2O is so insignificant, so negligible, that we can just ignore it. And it says gas mixture. This is a liquid. That's the key thing. This is a liquid. It has our standard state there, so we don't want that. If we did, then we would have calculated, but it just wants the gas. So the CO2 gas and the O2 gas, and that's how you'd calculate. Yeah, but we do not want the H2O because it's in liquid. And that is the end of question 7.